In this lesson, I'm going to talk briefly about arrays. I'd just like people to understand what arrays are in the context of SAS and what their main purpose is, how they can be useful. So arrays, generally speaking, when you use arrays, you're doing it because it helps to make your program more efficient and less error prone. And in the examples that I'm going to give today, arrays that we'll be using are simply referring to a group of variables. So imagine you have systolic blood pressure, diastolic blood pressure, weight, and age, and you want to somehow refer to all of those variables at the same time within a data step. And if you use an array to refer to these groups of variables, and you do so in combination with a particular form of a do statement, you can do some group processing of many variables at the same time, and as a result, things run a bit faster within SAS, but more importantly, it's far less coding and it's far less error prone than other approaches to accomplishing the same outcome. So let's take a look at some sample code here. Here we're working with, again, the master data set. You can generate the master data set in the SAS editor file that was provided for this lecture. So we're creating a new output data set called work.master1, starting from the input data set work.master. And then I have a bit of code here that is first defining an array, and then effectively we have an if-then statement combined with a do statement that is going to utilize the information provided by the array. Let's talk through this one point at a time, and then we can jump into SAS and take a look at how it runs on that side. So first is the actual array statement. In this situation, in this particular code, we're using the array statement, and that's simply telling SAS, I want to provide a name for a new array, and I want to define that array by providing some information about it. So the array statement is a SAS keyword. You have to type it in just like this, although it's not case sensitive, so it could be uppercase or lowercase. Following that, in this example, we're specifying the name of the array, and I'm going to call this array BPA, which is short for my own memory for blood pressure array. But this is a user-defined array, and you can give it essentially any name you like. The next thing I'm doing here is I'm specifying to SAS some rules about the array, and the first rule is how many elements are in that array. And in this context, elements is synonymous with variables because I'm using this array to define a group of variables. And then after I tell SAS how many elements it can expect, I'm actually providing the names of variables that I want to be held in the array. Now, an important point here is that you can set up arrays early on in your data step that point to variables that have not yet been created. So that's a possibility that you may use in certain situations. It's not the context of the example here, but I just wanted to make it clear that it is acceptable to put variable names here, even if the variable has not yet been created. But in this situation, I'm actually specifying variables that exist in the input data set work.master, SBP and DBP referring to systolic and diastolic blood pressure. So two separate variables. And you end with a semicolon. Then, my overarching goal in this code is to take values of 888 for the variables systolic and diastolic blood pressure and change them to missing. Because when we move on and we start doing analyses, we of course don't want a value of 888 in the data set for systolic and diastolic blood pressures because they're not, this is not a valid value. It simply is code in the original raw data set telling us that the participant was eligible to have a blood pressure measured, but for whatever reason, the blood pressure was not measured and therefore it's missing. So we want to change these 888s to missing, and we've done that previously with if-then statements where we had to have either one long if-then statement to subset the data set, or a series of if-then statements for each variable, changing the 888 to missing. And in this example, we're going to do the if-then statement, but the different approach is we're going to combine it with a do group and information about the array to do the exact same thing we've done in past examples, but to do it more quickly and efficiently with a bit less or fewer keystrokes. So these simply define the rest of the pieces of the array that we talked about. And now, if we move down to the do statement, I'm simply telling SAS do I equal 1 to 2, which simply means as I call out to the array, I want you to run the specific code for each element in that array, or in other words, for each variable up in this array. And I specify 1 to 2 because I want SAS to start with the first element in the array, which is systolic blood pressure, and I want it to do run through the code for each element all the way up to the second element. So in this example, there are only 2 variables in the array, and we say I equals 1 to 2. If there were 50 elements in the array and we wanted SAS to process for all 50 elements in the array, then we'd say do I equal 1 to 50. So next we just have an if-then statement, no different than what we've seen in the past. We're simply stating if some condition, then some action. And what we've done is we've changed part of the conditioning here. Instead of referring to a specific variable to define our condition, we're instead calling out to an array with this type of syntax. The name of the array, and then in brackets immediately following, I. And we've defined I here to take on values 1 and 2 iteratively. Then we're saying if this condition is equal to 888, then again, calling back out to the array, BPA I equals dot. And what SAS will do is it will start with the first element of the array, which is systolic blood pressure. And effectively what's going on behind the scenes is SAS will run the code if SBP equal 888, then SBP equal dot. That's for I equal 1, or in other words, the first element in the array, which was SBP. Then it will output that to the new output dataset work.master1, and it will start over again with this if-then statement, moving on now to the second element in the array. And the second element in this array is the variable diastolic blood pressure. That means SAS will then run the code if dBP equal 888, then dBP equal dot, and it will then output that information to the new output dataset work.master1. And it will go through iteratively all the way up to the last I specified. Here, the highest indexing number is 2, and so therefore it will only go through this loop twice, and then it will quit, and you have to specify an end statement anytime you have a do statement specified. So once we're done setting up our conditions that we want SAS to process, put your end statement, and you're finished. So now, by running this code, you will convert all values of 888 for the variables systolic and diastolic blood pressure into missing values. So it should be evident now that what the array statement is doing is that it's defining a set of elements, in this case variables are the elements, that you plan to process as a group, and it takes on this generic syntax. And then we've added in the additional do statement, and in this case the do statement is iterative, which means it's executing statements between the do and the end statement in a repetitive fashion. And the repetitive fashion is based on values of some index variable, which we defined as I in the previous example. Now sometimes if you're setting up an array where you're going to place a whole lot of variables, maybe you want 50 or 60 variables in the array, it can be a little bit time consuming to type them all out. So a quick shortcut would be to run proc contents on your data set and use the short option. By doing that, SAS will print out a list of all variables in the data set, and you could simply copy paste the variables of interest. You don't need to do this. It's not necessary to combine proc contents with the data step and the array that you're trying to create. Again, it's just a shortcut that can be helpful. So let's hop into SAS now and take a look at this in the code. So I'm setting up my initial data set master. Okay. So first I sort the data sets by the ID number, and then I merge the 4 data sets together. And the only real restrictions I've put so far in terms of subsetting is to say that with this if statement, participants need to be a member of all 4 data sets to be included in this new output data set, work.master. And I also deleted people who were under the age of 20. Now, as you recall, if we take a look with a quick proc freak at the variables systolic and diastolic blood pressure, we have values of 888. So there are 38 individuals who have an 888 for diastolic blood pressure. Again, this means they came to the examination, they were eligible to have had blood pressure taken. There was no exclusion criteria, for example, but for whatever reason in the baseline NHANES exam, they didn't get the actual blood pressure measured. So they were assigned a value of 888, and we need to somehow change that so that it doesn't get used in later analyses and skew the results. And if you scroll up to the systolic blood pressure output, you'll see that at the end of the distribution there are 36 individuals who also have 888s for systolic blood pressure. And we want to change those to a dot, basically, to a period to indicate that they're missing. So here's the code that we just talked through in the slides, in addition to one other example of how arrays can work. So this is the specific array that we talked about in the slides in row 28 through 32. And then down below I set up one additional array to show a slightly different example of how arrays can be used. So here I'm setting up an array. The name of the array is Miss A. There are 7 elements in the array, and those elements correspond to 7 variables in my input SAS dataset, work.master. The variables are SBP, DVP, height, weight, BP meds, age, and sex. And what I want to do is I want to delete all observations in the dataset that are missing data for any of these 7 variables. So in other lessons, we've seen that you can subset by using an if-then-delete statement. In other words, we could say if SBP equal dot, then delete, and so on and so forth. And this time I'm simply going to do it by combining an iterative do statement with an array statement. So what I'm telling SAS here is do I equal 1 to 7. And then I'm using a basic if-then-delete statement. I'm saying if some condition is met for each observation in the data set, then delete that observation from the data set. And what SAS is going to do is start by looking to the first element in the Miss A array. So it will look and see if systolic blood pressure is missing for that particular observation that it's processing, and if it is, it deletes it from the data set. Then it will move on to the second element of the array for the observation it's processing. If diastolic blood pressure is missing, that observation gets deleted from the data set, and of course SAS would move on then to the next observation. If it's not missing, then SAS keeps processing the same observation by moving to the third element of the array, and it checks to see if height is missing, and so on and so forth for all 7 elements of the array. So if any one of these variables is missing, it gets deleted from, or the observation gets deleted from the data set. If the observation being processed has a value for all 7 variables in this array, then it doesn't get deleted, and SAS moves on to the next observation and then processes this whole if-then statement for all elements of the array. And it will go through that step until completion and output the relevant information to the new output SAS dataset work.master1, and then we specify again an end statement. So I also included a drop statement, and all this does is it removes from the data set this index variable I that we created. In the do statement, when we say do I equal 1 to 7, that's actually creating a variable named I in the SAS data set so that that variable can hold the different numbers in the iterative process. These are indexing numbers. Don't get too concerned about it. It has really no impact if you drop I or not. A lot of people do it just to keep the data sets cleaner so they don't have this extra variable lurking around. But for practical purposes, it's reasonably unimportant. Again, you may see it in other people's code and some of my own, so I'm just specifying why it's there and what it means. So if we were to run this now, and then run our proc freak, we can look at the systolic blood pressure distribution and we see two things. First, no more 888s, and also there's no indication that there are missing observations, because in that code we asked SAS to delete all observations missing systolic blood pressure. And the same is true for diastolic blood pressure. There are no missing values and there are no 888s, and if we looked at the distributions for height and weight, sex and age, and BP meds, we would also see that any observation that was missing values for those variables would be removed from the data set. Just to be clear about what we're doing, none of this is accomplishing anything new. The end product is a product that we've been able to get to previously. It's simply a more efficient way of getting there. This second example below is a data step that will do the identical thing. It will give you the same output SAS data set. It would have the same number of observations. It would have the same variables. I've actually given it a different name just for this teaching example. But the content of Master 1 Alt and Master 1 would be identical if you were to run both of these data steps. Okay? So up above, to reassign 888s to missing, we used a do statement and an array. Down below, we simply did it with two if-then statements. Now, in a situation where we only have two variables to change, it may actually be quicker to just type it out without using do statements and arrays. But if you get a data set with 1,000 variables, and the convention is that any of those variables that have some missing data get coded 888, it's obviously going to be much quicker to use an array than to type out an independent if-then statement for every one of those 1,000 variables. And the same thing holds for this subsetting that we're doing here, deleting observations with missing values for a particular variable. It becomes much more efficient the larger number of variables that you want SAS to look at and make a decision about keeping or deleting based on whether or not the variables have values in the data set. And if you're interested, I also included this example in the slides. There are ways that you can create arrays that will refer to variables more broadly based on the variable type. So in this particular example, we have an array statement that's creating an array named num_a, and instead of putting a number in brackets to specify the number of elements in that array, we're putting an asterisk, which simply tells SAS, I don't know how many elements are in the array, you go and count it and figure it out. And then using the numeric keyword, _numeric_, SAS will include all variables in your data set that are numeric. So if you have 1,000 numeric variables in your data set, by specifying numeric, there will be 1,000 elements in this array. And then down below, I'm again trying to process all those variables and make sure that all 888s are converted to missing. And we can simply doing that by saying do I equal 1, 2, and instead of specifying the top index number or the number of elements in the array, since we don't know them and we don't want to hand count 1,000 different variables to be sure we get the exact number right, you can specify a dim option, and then, which is short for dimensions, and then in parentheses specify the name of the actual array. So what this basically does is it will go through an iteration starting at the first element of the array stated, and here's where we're stating the array, and it will go all the way up to the last element, and the last element is determined by SAS when you use the dim num_a. So SAS will jump up to the num_a array, and it will count how many elements are in the array, or in other words, how many variables are numeric in that data set. And it will replace this with that value in your internal processing. And then again, you just use your if-then conditions, and again, the conditions are only slightly modified so that you're pointing to arrays rather than actual single variable names. Again, you have an end statement. If you wanted, you could add a drop I statement, but again, it's not necessary. A couple of warnings about arrays. Using the name of a SAS function as an array name can cause some unpredictable results. So just be careful when you name the arrays. Try and give them a fairly unique name so they don't possibly overlap with the function that exists in SAS. I would also avoid using variable names from your data set as array names. And then array names have to follow the rules for SAS variable names. But again, they shouldn't share the same name as a SAS variable in the data set. And we've talked about rules for SAS variables in previous lessons.